right, so we're going to talk about divisibility tests in this video. And here's the idea. You've got some group of objects. Let's say you've got a whole bunch of children, and you want to know, for example, if you have enough, so basically say each child has 4 things, right? And you want to make sure that you've got the proper number of items, right? And so what you would have to show is you'd have to show, say, like the thing is divisible by 4, or if you're trying to give one to each child, let's say you have 16 children in this, you need to make sure that the things that you have is divisible by 16. Okay. This is what's called a divisibility test. So we will develop divisibility test for a bunch of different numbers. So 3, 4, 5, 8, 9, 10, and 11 are the big sort of standard ones. And what you're going to see is, for example, and I didn't say 2 here because divisibility by 2 is the same as even. That's kind of fairly straightforward. And so, but that's an example, right? So I can look and say, oh, okay, I've got 1,358 things, and I want to see if that's divisible by 2. And remember, we just have to look at the last number in that. So for example, in 4, we're going to see if we take that same thing, divide the last 2 digits by 4, whether or not that's, that will tell me if something is divisible. Okay, so before we get to that, let's do a few little things. And this is a definition. So remember, in one of the previous examples, one of the previous videos in this sort of group, is that we want to, it's really important to sort of define what we mean by things. Okay. So we say some number A is divisible by K, by another number K, if there is a number n such that A is n times K. Okay. So this is going to be the general thing. You know, we say, for example, 10 is divisible by 2 if there's some number n, right? So that 10 is something times 2, and that something is 5, for example. Right? Okay. The other thing I just want to point out is a lot of this in this chapter we're going to be doing sort of more sort of algebra level things, so using variables. And if I do that, I'm going to drop the using the x or cross symbol for times, and either use dot or just do nothing. Okay, it's really confusing to use times when you're doing things with variables because of it looks like an x. Okay, so one of the other things is the following are equivalent. So we might say A is divisible by K. We can also say K divides A. We can say A is a multiple of K, or K is a factor of A. Okay, so it all comes back down to here, and basically, in many ways, these are just sort of alternative ways of explaining that little relationship. So K divides A. So basically because of this, and I'll show an example of this a little bit later, A is a multiple of K. You can see a multiple just means that it's some number times K. That's exactly what we mean by that. And K is a factor of A. So remember, if I have a product, this is a product, the two numbers in the product are a factor. So we say that. All right. And then one more thing on this. Let's write down the quotient remainder theorem again. So this keeps popping its little head up over and over again. So let A and K be positive whole numbers. Then there exist unique numbers Q and R such that A is Q times K plus R, where R, oops, where R could be 0 and up to but not including K. All right. In this sense, there's not much room here, sorry. Divisible means R is exactly 0 in this case. Right? So we're using a different letter here, N instead of Q, but means the same thing. All right. Let me show a couple of other things related to this. I'm going to talk about some grid diagrams with divisibility. Okay. Okay, so I'm going to say 15 is a multiple of 3, and remember I can do the equivalent things. I could say that 3 divides 15, 3 is a factor of 15, right? And so on. So one thing we can do with this is a grid diagram. Right. So I've got 15 little boxes, and I can put them evenly into sort of 3 rows, right? So there's 15 squares into 3 rows and no remainder. Remember, we've done this before when we've shown something has a remainder and there's some number, there's either 1 or 2 boxes left over like that. So when you say something like 13 is not a multiple of, say, 4, because what I'm going to do one, 2, 3, 4, another 8, 12, 13, 4. 13 is not a multiple of 4. I already wrote that down because there is an extra box remaining. Okay. So you can always do all of these things with grid diagrams, although it might get a little bit big. And I'm going to show you that too. So the other big thing about this is using some long division. Let's take a look at that. Divisibility and long division. So the big thing with that we just saw is if we do division on a problem that's talking about divisibility, then we need to just show remainder 0. So here's the question: is does 9 divide? What do we have? 4725. Question mark. Okay, so this is an example that I don't want to do with a grid. That would mean writing down 4,725 little boxes and really making sure it's right. Okay, so let's do long division here. Okay, so again, 9 doesn't go into 4. It can go into 47 though, 5 times. 2 left over, 2 down. 922 goes twice, 18. 4 left over. Bring the 5 down. 9 goes into 45. 5 times is 0. Right? So since the remainder is 0, 9 is a multiple of 4725. Okay, so I have a couple more examples here, which we're going to do a little mental math on. Before I get to that, let me just talk about this. We are going to learn a way to look at this number pretty easily to see if 9 divides that. Okay, so basically we'll learn sort of some mental math tricks to do this using some what are called divisibility tests. So we'll get to those a little bit later. Okay, let me do one more. To show, let's see, 912 is divisible by 3. Okay. So basically what we're trying to do is we're going to try to do this, right, in our head. And the way that I would look at this is I'm going to write this as 900 plus 12 divided by 3, right? And I know that's 900 divided by 3 is 300. 12 divided by 3 is 4. Right? So no remainder. So yes, 912 is divisible by 3. Okay. All right, so this just starts out a little bit of divisibility. Just a little recap. We talked about what it means to be divisible. There's all these different ways of saying it. Notice I keep changing this kind of stuff up. This is very common. There's all of these are used in sort of different ways. So you sort of got to get used to that. We talked about grids and making a grid to show divisibility. And then once the numbers get bigger, either doing a little bit of long division to show things, right? And the big key thing is that there's no remainder if things divide through or divide evenly. And this shows a little bit of mental math on that. Okay, so that wraps up this video.